if I were to switch account. Wait, can I hear? Wait, I need to try something. Can I hear anything? Why am I Great Britain? Fuck it. Can I hear? Oh yeah, you can! Okay. Can I hear from outside without headphones? I can, okay. Do I need headphones? I get headphones. I have to leave. I'll mute here. To be fair, don't know what work needs to be done. Math, and then like normal work. Oh, that's nothing. Physics, sound, chemical bonding, chemistry. Okay, in order of stacking, I think I will start with 1 on the chemistry. We tried! I'll hold the audio, it's fine. I don't give a shit. Should I do? Let's do multiple choice first. At least if I get this done, then I can get it out of the way. I'll do chemistry first. Should I do chemistry first? Yeah, fuck it. Where's my pencil? I have to play a mix, eh? There we go. Right, is that how I do it? Yeah, sure. Huh? What did I do? Did I start? Oh, whatever. Whatever the hell. What do I need to do? I want to load something. What do I do? This. Okay. Oh. Fuck off. How long is it? 45. Alright, time now is? Okay. It's so low, the fucking one on my side. If it's seawater, okay. Yeah, by that logic is D. So we want 100 cause seawater is impure. By if there's impurity in anything, it will increase the boiling point. But here is water, so for it to condense, it needs to be less than 100. Yeah, okay, D. Oh, they have the periodic table on me, eh? There's one in the back. Is there periodic table? There is. Too lazy to start off the back. Periodic table. Periodic table. Yeah. I didn't need to know mass level, so this is what this is just thinking on. So here is air. The two different gas or beakers are inverted. So the way that this is which pair of gas will make the water level at S rise the most? So for it to rise, it needs to less air. There needs to be less air here and greater air here, so that it pushes this down here. So T should have a light, something light, so that it can move faster. And here should have something slow. So heavy. So here is light, and here should be heavy. So which of these two is lighter? Hydrogen. Hydrogen H2. Hydrogen is 2, 2, 2. And H4 for nitrogen is what? 14. So it's NH3. Sorry, NH3 is hydrogen. Is ammonia. N is 14 plus 3 hydrogen. That's 17. So 17, 17. Out of these two, only hydrogen is fastest. Hydrogen is lighter, so it's faster. So it's 17 versus CO2. CO carbon is 12 plus 6, 32. So which equals to 44. So we want the heaviest one, D. So D is the answer. This shouldn't be too hard actually. I can complete it in 45 minutes. Actually, oh, now I'm realizing something. Why don't I flip this the other way around? Now you can see what the hell I'm doing. Alright, anyway. The mixture of sulfur and iron filling needs to be separated. The solubility of sulfur and iron filling in water and in carbon disulfide is shown in the table below. Both are insoluble in water, but sulfur is diluble in sulfur disulfide. By that logic, what we can use, the following ways can we use to separate sulfur and iron fillings. We can use a magnet, that's for sure. So because this is attractive, it's a metal. So metal should work. So this two is out. I should focus on whether you can use water. You can't really filter your water, so whatever the answer here doesn't really matter. No, it does. You can't separate your water, so the B is out. Yeah, you can only separate it using copper disulfide. So C. Okay, so the measuring cylinder. So the correct reading of the barrette and the measuring cylinder. You want to read by the lowest point, or where is it? Yeah, where it dips the lowest. So here and here. So 41, 42, 44, 42, 44, 46, 48. Yeah, so it's 44. And on the barrette it is, what's that, 0.8? Oh, okay, because here is 27.5, because it's halfway. So here goes, so this is 27.52, right? So here, right? Am I right to think that? 2.22, yeah. No. What's the increment of this? Oh god, okay. There is how many gap between 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. Then what am I doing? Okay. For barrette, you read from top to bottom. So you read from here to here. So here should be 27.8. Yeah. You don't read what's left. Oh, okay, no. What's left is what you calculate afterward. It's the calculated value. So you just read what's the current value here, then you minus it off, then you get what's left. Alright. Yeah, I'm gonna take. Okay. So 50-50. Forget which way around you read it in. But I'm gonna trust my gut that it's D. You just read whatever value is on it. You're just supposed to read it, you're not supposed to calculate anything out of it. But then by that logic, you know what, fuck it lah. By that logic, it wouldn't make sense. Cause it is, you know what? B. That shit. Isotopes don't... Isotope has the same chemical property but not the same physical properties. Isotope has the... Cause the only thing that differs is the number of neutron. However, it's pure neutron. Diff. So by that logic, since this, you'll change the physical property because it increase mass. So 3 is out. Anything with 3 is out, and then 1 is true. Both had the same electronic configuration because they're both chlorine. So 1 and 2. And proton number. What is the molar mass of the compound formed between the two elements? Okay. Can you figure out what these are? Proton number is 13. So M is aluminium, which is a non-metal, which is a metal. So whatever bond is gonna make probably is gonna be ionic bond. So here is oxygen. So it's gonna form an ionic bond. But what's the ionic bond ratio? It needs to be, here is group 3 and here is group 5. So it's Al2, yeah, Al2O3, because you have how many remaining? You need 2. It needs 2 more to form whatever is into neon. It needs to shift 2 more. So times by 3, and then here needs to aluminium needs to remove 3. So yeah, it needs 2. Yeah, okay. So I am right. So it's Al2O3. Then you take the nuclear number here and then you add it out. So 16 times. Wait, I have a calculator on me. I'll do it here. Calculator. Okay. 16 times 3. Shit. 60 times 3 plus 27 times 2. So what's the molar mass? 102. There we go. See. This shows the 4 substance of PQRS. PQRS, okay. These are the correct identities of the 4 substances. Okay. These all are high except for this low. By that logic, this should be a simple molecular structure. So which of these are a simple molecules? Sulfur. So C is already out. So soluble in water, meaning since this is the only one soluble in water, it means that it's either it's ionic. Only ionic is soluble in water. So which of these are ionic? Sodium sulfide? Seems like it. So B is out. Then we look at this one. Since we already figured the identity, we don't have to really look at these two anymore. But we have to look at this one. Conducts in solid state. Does it only conduct in solid state? Well, whatever the so since this is, so most likely this probably is leading us to think it's a metal. So which of these Q is a metal? Graphite. Not metal, sorry. It can be a metal or something that just conducts it. Okay, metal. However, okay, that's my first guess is metal. We look here, Q, there's no such thing, there's not really a metal in here. However, we know graphite can conduct, so D. How electrons are not involved in the chemical bond of one. Only okay. Wait. The guy shows a structural formula of the covalent molecule isopropanol. Propanol. Maybe. How many electrons? The way you get remaining electrons is when you have more than one shell, so that the inner shell is not used at all. By that logic, hydrogen is out of the question because hydrogen is already sharing its 1 electron with this. So we should only look at all of this carbon, oxygen. Okay. So for this carbon, it's sharing 4 already. So 2 is left here. This is the inner shell. Same for here. 2 is being shared. Here, 2 is not being shared. Here, okay. Here, right? Oxygen needs 2 more. So out of that logic, So since it's only sharing 2 bonds, we take whatever it has, which is 8 minus 2, 6. Yeah, you have the inner shell and then 4 of the outer one. Right? Am I right to think that? Oh, I'm drawing valence electrons. Yeah, I actually need to share with 2 carbon, and these 2 carbons need to share one each. And then since it's already, since there's 6 more, 1 2 3 4 5 6 1 2 3 4 5, no, it's already at 6. 1 2 3 4 5 6 7 8. Yeah, okay, so only 2 is being shared here. So you just take the number of bonds and then you just minus it off. That's a simple pattern. So here's 2, here's 2. So add this all out. Oh no, you also have this oxygen up here. So since it's sharing 2 bonds, it's only 6. So by that logic, 2 plus 2 plus 2, which is 6. 6 plus 4, 10, 10 plus 12, 24. 10 plus 12 is 22. Oops. See. Two jars are set up as shown. 2 jars. 2 jars are set up as shown. The lid is removed and the jars are left to stand. Okay, after a long time, the content of both jars are pale blue. Which particle okay, copper 2 sulfate is a molecule, so this is out. Then it's not really copper atoms. So is all 3 of them moved? What makes the most sense? Go up slowly view. I don't know what the hell I'm listening to. But you know what? Fuck it. Oh, my nose hurts. Copper wires are used in power transmission. Which particles are responsible for the conduction of electricity through copper? Should be electrons. Should be electrons. There's no negative ions in copper wire, so it just should be electrons. Right, unless both of them move. No. The copper atoms don't move. Yeah, okay, so I'm gonna guess A. No, that makes no sense. Should noble gas X, Y, Z have constitutive if Y is a noble gas? Oh, why have I feel like I've done this question before? Okay, if Y is middle, if Y is a neon gas, Z is a metal, or group 1, or X is a non-metal of group 7. The fuck is this song? You know what, I'm skipping it. Oh, chey. Which of this statement is true? Let's not set between X and Z. They don't share. They are transferred. So you see, this keyword makes all the difference. Since this metal non-metal is an ionic bond is a transfer. You have to get it in there. Then carbon decomposes to form zinc oxide and carbon dioxide. Okay. So it's a 1-to-1. That's all I know. Okay, it's 1 1 to 1 to 1. No, arrow up. 1 to 1. Okay. So from zinc oxide, what is the mass of 1? So this is 1-to-1. What am I supposed to do again? Oh shit. God, I forgot to do this kind of question. Just to find back how many I get here, and then take it over here, and then percent. Okay. Let me think about this. How am I supposed to do this again? Okay. We need to find molecular ratio. Oh, okay, finally got it. Okay. Zinc is, oh, that took quite a long time. Okay, 65 plus, okay, this is zinc and this is zinc carbonate. 25 plus 12 plus 60. Oh shit. Oh god, okay. $65 plus 12 plus 16 times 3, so 125. So for every 125, oh, so the ratio is 1. So that's exactly 1, what do you call it, 1 mole, molar ratio. Okay, 1 mole of this will produce 1 mole of zinc oxide. Zinc oxide is 65 plus 16, which is 71, no, 81. Okay, so 81. It's supposed to produce 81 Gs or grams of zinc oxide. However, it only produces 65 plus 16. Okay. However, it only produces 27, so we take the ratio of pure to 81 times 100%. We get 27 divided by what is this? Divided by 81. Equals to times 100, 33%. So there's a B. I hate this. Contains the same we can contain the same number of total of atoms as 300 dm cubed, which is 1 mole. Whereas assume all gas are room temperature room. So yeah, there are 1 mole of any gas at 24 dm cubed at room temperature pressure. Okay. Am I not retarded? Or is it not this? Total number of atoms. To count the total number of atoms. Oh, atoms. Okay. Boom. Atom. It's not molecules. So how many atoms are there? Hydrogen gas is H2, right? So there are 2 mole of atom. I hate this damn question. Okay. Methane is a NH3? Yeah, NH3, which is 4 times that is 48. Wrong. Ammonia, wait, argon is 1. Oh, cause it's a normal gas, so it's argon. Okay, so it's D. Oh yeah, oh fuck this question. Actually, what coefficient of PFQ is needed so the balance the following equation? Okay, the only way of you getting, since these stays the same, you need at least 3 of these because of these 3 down here. So you at least need a multiple of 3 for Q, so 2 won't work. However, you also need the same number of, you need an even number of hydrogen so that you can form S number. So you can't be 3 exactly, so it's 6. By that logic, S has to be a 3. So this is out, this is out, these two are out. So C is the only correct answer. And let me just check. 2F, 2F, yep. Because this is already been controlled by that. Yeah, okay. So let's see. I mean 6 because this 3 only applies to this whole thing, not the F itself. ATP contains 18.3% by mass of phosphorus. It's shown that the relative molecule of one mass is 507. How many phosphorus atoms are there in one molecule? Okay, how many atoms are there in one molecule? Okay, so we take so we take 507. Okay, let me do here. 507. You want to find the number of phosphorus, the mass of all the phosphorus. So it's equals to how do you do this? Opposite. Okay, so there are at least 94.809 grams. Mass of phosphorus is 31. What? 31. Can we just assume it's 3? I'm gonna yeah. In this because this is a base, right? There's a base and ammonium reaction, right? Am I not retarded? Base ammonium reaction. Yeah. Base ammonium salt reaction. Yeah, reacts with bases. Yeah. It's just that the only reason is just called the produced ammonium. Only salt can be prepared against in a given method. Ammonium sulfate. Table of solubility. That's the easy way of memorizing this, right? Hey, well, let's do a clear one. I know. That's all I need. Yep. Okay. Titration can do anything, right? God damn it! What's the table? It's like you start here, and it either leads to excess reaction, or based on something you need to titrate, or soluble or solution, something like that. Okay. There's a reason here and a reason here, and I forgot those two. God, add excess zinc carbonate to nitric acid. Something to do with span and spa. Okay, this this is precipitation. Okay, this precipitation excess, and then this is nitrate. Okay, lead 2 is insoluble, so it will precipitate out. Therefore, you can't do excess. You can't do excess of it, because if you do add excess, the extra powder might lead to be mixed with the soda. Yeah. So this is not wrong. Oh, okay. Then B lor. The fuck? Any question? That's 125. Oh, okay. 9 more lor. Okay. So thermal blue is, if I write 1, 2, well. So this is P. Okay. Red 1. I do 1 3 5 7 9 11 and then 13. Sure. So red, blue, clear. Oh, I'm not gonna say clear because I'm too right to like colorless, but it should be colorless. So onto here it changes. 5 it changes, and then 3 it changes. From here on out it's yellow. From here on out it's red, and from here out it's pink. Okay. So if this is yellow, it means that it has to be greater than 3, and this is red, it has to be greater than 5. But if this is colorless, it has to be less than 10. So I'm gonna say pH. The pH is less than 10 but greater than 5. Shit, that's how it works. It's greater than 5. So it can't be 4. It's in the point. 5 and 10 is smack dab where water is, which is 7. That's neutral. Hydrochloric acid is too much, if I remember correctly. It like contains potassium chloride or potassium hydroxide. See? Make sure your damn doesn't get. Alright, I don't know how any of these works, but I will assume you have to bubble it through something. You want to collect hydrogen gas. SO4. No, HSO4. SO3. No, it's SO3. Sorry. Reacts with HCl. Oh god. Okay. Another day. Oh no, that's a colorless solution, so you can't precipitate. So as long as it doesn't contain lead, silver, barium, calcium, or lead, or any carbonate, or any phosphate, or hydroxide, then it should be fine. So this one forms silver chloride, which won't work because it's insoluble. This produces, this is a base plus acid, which should be neutralized because this will produce water. It's not swap, and then it's a nitrate, so it should work. Then I try the other one. This produces copper sulfate, and this is where I start to lose all hope. This produces water plus calcium nitrate, and nitrate is soluble. Maybe together will produce a colorless solution. However, copper sulfate, doesn't copper sulfate has a color because it's a transitional metal? CuSO4. Oh, it's also SO4, not SO3. I was wrong. It does have a color. So even if it is soluble, it's gonna have a color. It is blue. It wants a colorless solution. So this will be blue. Won't work. And here produces iron oxide and sodium chloride with won't work. So it's only B. Then you carry the following experiment on polluted water. Ya Allah. Wait is it gas test? No, right, it's metal test. Check this for metal. Check. Where what you do? Test testing for anions and cations. Where does like the sheet that it comes from come from? Where's the sheet? Come on, there has to be one. There has to be one guy that like decides to scan it. Yeah, screw it, I'm using you. You explained more than enough to me. Okay. Yeah. Both. Fuck. Occurs ammonia, what precipitate that is soluble in excess. Okay. This is testing for. This is anion test. Not here! But yeah, okay. So we know that the metal is zinc because it's soluble in excess. Oh, why is this wonky ass stick? But yeah. So it's zinc. Okay, then you go find a better damn image. That's so shit. I can't think. Okay, so you add nitric acid, these two, and then you add silver nitrate, or he added what, barium nitrate, and the white precipitate is formed. So is it sulfate? I'll put B. So I actually can't think. Edit. The highest temperature is where all of the nitric acid is able to react with the sodium hydroxide. So that should be complete neutralization, should it not? The reaction doesn't have a negative doesn't have a positive entropy. It should be negative because it's losing its energy to the surrounding. No. In case just a. Yeah, I'm not recommending to you. Whatever. This also is endothermic. Endothermic is basically when you start feeling hotter. Melting of ice cube. The melting of ice cube is technically. Wait, okay. Oh shit. Endothermic is when you're forming bonds, right? Ya Allah. Because my computer. Okay, let me think about it. From liquid to solid, you're forming bonds to get the thing back together. So by melting your ice cube, you're releasing bonds. By forming bonds, you're losing energy. Right. So I'm damn dumb. Just due to it, duh. No, fuck, what the hell? Yeah, energy released when new bonds are formed. Bond making is an exothermic term. So, freezing an ice cube is an exothermic process, while the melting of ice cube is an endothermic. Other way. So 2 is right. So if it doesn't have 2, it's wrong. Okay. Thermal decomposition. If it decomposes, doesn't mean that. Okay, you know combustion of carbon. So carbon to form carbon gas and dioxide is the forming of bonds. So you're forming bonds anyway. It's combustion, so that's already wrong. It's not 4. So the only thing that differs is whether 1 or 3 is right. Thermal decomposition of nitrogen. Decomposition is an endothermic process. Okay, done we can. Oh, I'm done. Yo, did it. Go away. Well, my YouTube fucked up, bruh. Let me start on the bigs of this. 6 o'clock I'm going off. Okay. This element extinguisher lighter plate with a pop sound. Oxygen? My oxygen is reduced. Oh no. Okay, oxygen or hydrogen? Fuck, I'm so bad. Hydrogen is present. So just use the symbol H. Thank God I'm doing this now so that I can get into the flow of things before school starts. Oh my god. Yo, anyone want to sniff some sulfur dioxide? Choking smell. Yeah, anyone want to sniff some sulfur dioxide? Okay. This element forms a cation ion that has a charge of magnesium. Oh dear. Am I retarded? Oxide. What's an oxide? What's an oxide? It's a molecule. Oh, silicon dioxide. Okay. Hey, can I use more than one? These elements attain a octet structure by forming a single covalent bond. Is it not these two? What is this? Yeah, fuck it. This element forms oxide. We can react with both hydrochloric acid and bases. The oxide! I remember aluminium. What form is what's amphoteric? I mean, if I check here, I probably can find which one's amphoteric. I know there's a way. What? It's amphoteric. I know it's something to do with amphoteric, but I can't remember which element for amphoteric or why. But it should just be it should be silicon, I think. Pencil. Where's my pencil? Here. Draw a dot and cross diagram. Sort of the formation of hydrogen. So only the outer shell. How do I think hydrogen looks? There's two ends. So what I think is 2 1 1 1 1 and H H H H. That's what I think. I don't think there's a H here. Anyway, if there is, it won't work. That's how I think it is. H and H. Oh, this is way too small. The amount of space they give me is way too small anyways. Cause some school decided to put it on half-sided paper. H and that. Okay, that should be the dot and cross diagram. We can fact check it. Hydrazine. Seems like it. Oh, it's nitrogen, not carbon. Oops. It's only in group 6. It's only in group 5. And then there's, by that logic, there's 2 more. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh my god. Alright, wait, let me take a bit of a detour. You know what? Too much. Oh, there's an intensity level. Let's make it way too hard for ourselves. Okay, anyway, let me just can I click? Oh, there you go. Okay. I think it'll be fine. Let me check the booking. And that's alright. Oh, true. I forget I keep having this on. Bodo, come back. Friday is what day, 10. What's up? I like formatting things way too much. Alright, anyway, back to what we're trying to do. Okay, that's hydrogen. Using ideas of bonding structure, why does hydrogen have a low boiling point? Molecular. There you go. Use the data to calculate the enthalpy change for direction in equation 1. God damn it. Okay. So, hydrogen. How is hydrogen arranged? It group. Hydrogen peroxide. How is it formed? That's hydrogen peroxide. It looks like. Basically, just HOOH. Look a face. Okay. And then hydrogen is HNNHH. It's the sleeping with eyebrows. Okay. Okay. So what does it form? It forms nitrogen with steam. With steam. Yeah, it tells me already. Okay. Okay, so there are two of these. So okay, so energy so there are how many HO bonds are there? There is 1, 2 times 2, so 4. 4 HO, which is HO is 460 times 4, which equals to 460 times 4. What? Action cannot be formed. What? I need to open chat in an interactive browser. Sorry, I can't access live chat in my account. Oh, probably got on a different account, aren't I? Bastard! That's retarded. I hate this. How am I supposed to chat? Brother! Wait, YouTube? This is painful. Hey Arash, you want a song? What is this? Can I add a song? What song should I add? I don't know. No. You know what? What are you doing? my work. I'm gonna get distracted. Okay, what was I trying to do? Arashi! Alright. Okay, trying to do the bottom one here. I want to try to open up a calculator. That's what I'm trying to do. 460 times 4. 1804. 1840 joules. Joules. No, kg. Okay, so we have what? Okay, now we need to do the OO ball. 2 OO bond. OO bonds are 150. 150 times 2 is equals to 300 kg. Then we have 2. What next? We have no, not 2. God. Okay, so we have basically completed shit. Can't do this right. God, stop. Stop. Why am I playing? What's this song? Midnight Circulation. Yeah, why? Ya Allah, I swear to God, this thing don't behave. Oh my god. Wait, how do I deal with this? Okay. How do I even make it so that my cursor is like that? What do I do? Well, how do I do? How do I this is why I hate my function. What do I do again? Oh, this is why I hate computers. computers! I'm so done. Can I do my damn work? Stop messaging me! Alright, okay, now back to where I was. I need to solve for 4 HN, which has 390 times 4. Yeah, I'm not gonna ignore all my damn messages. 1560K Joe. Then I have my NN. 1 N is equals to 160 times 1 equals to 160K Joe. So okay, let me solve this total. Let me solve the total. Okay, 1840 plus 300 plus 1560 plus 160 equals to, there we go, 3860K joules. Energy forming. So we got water, which is H2O. There N2, which is N2. So we have 8 OH bonds, which is 460 times 8. Three six eight zero 1 and beep 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 994K joules total. Yeah, plus 99 plus 994 4674 kilojoules, and then F4 and 12 we change is equal to 3860 minus 4674, which equals to 3860 minus 4674. There we go, minus 814 kilojoules. I'll die. Oh my god. Dad. What's that? Daddy. Why do some aluminum as a propellant? Describe the bonding structure in aluminum. Propellant as it? What about aluminium? Aluminium forms how do I open up emoji? Oh, here you go. Wait, let me think about this. Wait, give me a sec. Okay, if I have the letter M in my cipher and I know it's I. Oh no, you can't get the running key. Okay, dimetallic structure. What I write here? Okay. There is a strong electrostatic force between the aluminum cations and sea of electrons. Are these? Alright, well, I need to do at least some of the other things. At least I did some of my work. And fucking others. Alright, I think I'm done. He tried to complain to me about how I pronounce aluminium. Aluminium.